Okay, dear students, so let us talk about the bound state, which is very important. So, in this video, we are going to comment about what kind of energies are manipulated here in the satellite motion, what is actually happening here that we want to study. This topic is very important, but ironically, this is not given in that much detail in the books or even in the data booklet. You won't be finding the formulas, so be very careful. So, the first point is when the satellite is at a distance of r from a planet or from an astronomical body, number one, it will be having a potential energy as we know it. So potential energy for the satellite motion, we can just take this formula from our earlier videos. The potential energy will be given by a negative gmm by r. It is always negative and it becomes zero only at infinite distance. So we know it that at infinite distance, like with respect to the earth, uh, the potential energy is equal to zero. Otherwise, it just becomes negative. So this is negative. Now, this thing is done. What about the kinetic energy now? Because we're talking about the satellite motion, so now we know the expression for the velocity. So the kinetic energy is given by half m v naught square because satellite is supposed to be moving at a constant velocity. So this is the kinetic energy simple. I am going to substitute the value here, which can be written like this. And on solving it, we are getting number one a positive expression, and the expression is gmm divided by 2r. Here for the potential energy there is no 2 in the denominator, but in kinetic energy there is a 2 in the denominator. It is half in magnitude when you compare it with the magnitude of the potential energy, but not the negative sign. Okay, so this is the potential energy. You can just remember it. This is kinetic energy. If you remember it, it is very good and highly advisable that please remember this. If you can't remember it, this is the way that you can derive this formula every other time, because this formula is given in your data booklet, but still it is highly advisable if you can remember this, please. And this topic is one of the very important topic. There are so many questions in paper one that IB has asked where this formula is directly applied. That is why please remember this formula. Now, let us find the expression for the total energy. We are going to just sum total these two. So this is negative gmm divided by r plus gmm divided by 2r. So gmm by 2r is basically half of what negative potential energy is. So total energy is having this expression now. Students, those who are having problem how I have calculated this, please try to go for algebra, try to take things common and try to do it by yourself. Take the LCM and you would be getting this answer. There won't be any big problem there. So total energy is negative. What do you mean by negative total energy? Negative potential energy, we understood that infinity, it was taken as a reference, so it was zero. So as you keep on coming near to the surface of the planet, it becomes even more and more negative. But as for the total energy is concerned, it is really weird. The total energy is negative. Well, this is why this system is known as bound state. So when the total energy is negative, it is called bound state. It means the satellite is bound with the planet. Obviously, there is no string attached. There is nothing like why is satellite attached to the planet? You will say it is because of the forces. Yeah, I understand that. But apart from that, it is still in space. I'm not talking about the forces because now we are talking about energies. So, from that point of view, we are not catching it with kind of a string or a rope. It is not bound. It is having kinetic energy. Why it doesn't just move away like that? And the reason for that is from the energy point of view that the total energy is negative. This is called bound state. So you have to remember these three formulas, people. Potential energy negative gmm by r. Kinetic energy is positive gmm by 2r. It is half of the potential energy. And total energy is again negative but the magnitude of total energy is equal to the magnitude of kinetic energy. Quite ironic, but this bound state is very important for us. Now, the similar bound state case will be undertaken when we will start learning our topic E, when we talk about the nucleus and the electron motion. At that time, also, we are going to invoke the same principles. So, this principle is again, it is becoming even more important. So, you can just remember this. This is the bound state. Now, what are the conclusions that we can draw? But from the potential energy, now we know that farther you move in the orbit, it increases. So for this, if R increases, the potential energy also increases. It becomes lesser negative, it is increasing. So you can think from that point of view. If the radius is increasing, so the magnitude of gmm by r is decreasing, but because it is negative, it becomes lesser negative. It means potential energy is now increasing, moving from negative 50 to negative 30. Now, if we talk about kinetic energy, again, the radius is in the denominator. You increase the radius and the total magnitude, it is becoming lesser and it is positive. So the magnitude is becoming lesser and it is having a positive value. It means kinetic energy is reducing. So if kinetic energy is reducing, so I can write if the radius increases, kinetic energy reduces. Well, a similar thing can be said about the total energy, similar to potential energy, that if the radius increases, the total energy is also increasing because the total energy is negative. And at infinity, the total energy becomes zero. At infinity, potential energy is zero. And at infinity, we will assume that the kinetic energy will also become zero. Okay, so this is what is the bound state for you. And the only thing that is left now is the graph. So how does the graph looks like about the energies of a satellite? I'm going to draw here, like this is the y-axis. So on the x-axis you have the radius. So the kinetic energy is always positive, but it is always reducing, and it is clearly the hyperbolic variation. So kinetic energy will vary somewhat like this. As per the potential energy is concerned, potential energy will be varying like this, but the magnitude will be double the kinetic energy. And when you sum total it, the total energy will also vary somewhat like this. It is always going to be negative total energy. This is the potential energy, and this is kinetic energy. Kinetic energy is always positive total energy, and the potential energy is always negative, whatever be the radius of this. Now, this is taken from like it. The graph starts from the radius of the Earth. Like this is the surface of the Earth or the surface of the planet. So the graph starts at the surface of the planet. It does not go into the planet. We're not even commenting on that. So this is it. The radius can go up to infinity. That's it, my dear students. So this is everything about the satellite. In the last video, I told you about the satellite motion, the velocity, orbital speed, and the time period. And in this video, we talked about the bound energies, bound states. This is it. All the best. Thanks for watching. This is Professor Varun. Bye.